Alright, we're go-to-math.com and click on the calculus button there because there may be others. We're looking at the numerical approach of finding a limit. And this is the section here we're in, and I believe that's the problem we need to be looking at right there. Okay, so we want to evaluate this numerically. We got the limit as x approaches -5 of x squared minus 25 over x plus 5. So let's move over to the whiteboard and write all that up. We got the limit as x approaches -5 of x squared minus 25 over x plus 5. And I'm going to write this. If you've watched any of the other problems, I'm pretty much, following the same procedures. Hopefully you've caught on to what's going on by now if you've worked any of the other ones. So what we're going to do here is I'm going to factor this, and kind of reason for this, get you ready for the next section. And it's over x plus 5. Now, I'm going to rewrite this function f of x is equal to, once we cancel out some like terms here, whoa, I meant to cancel these two out and keep that one, sorry about that. Alright, we're keeping that one. These two here get canceled out. So we got x minus 5. Now, these are two completely different functions, as you can see here, but if I was to state the domain here, of course the domain of this guy is all real numbers, but we're going to throw a number out, and that's going to be -5, because if I plug -5 into the denominator, we end up getting 0 here. Of course, we also get 0 in the top, and usually 0 over 0 means there's a missing point in the graph somewhere. Just a hole, not a vertical asymptote or anything like that. Okay, so now these are both the same. As long as I throw -5 out of the domain, these guys are both the same function. They just look different. Now, I guess the next thing to do is kind of sketch out what this graph looks like, which is really important to kind of hold what we're doing in memory. We have a slope of 1 across at -5, so it's kind of down here somewhere, we will say. And you know what? I should have, hold on just a second, we're going to do some erasing. Okay, when I saw what the graph is probably going to look like, let's do something else here. Okay. We're going to say this is -5 right here. And of course, we're approaching -5, so we're going to say that this is -5 right here on the x-axis. And of course, we got a missing point in the graph, and then it looks like that. Okay, so this missing point right here is, we'll just call this L, is what we want to try to find. This is, where is this located? Now, we don't know where this is at. What is this L value associated? Is Y value associated with it? We don't know, because when you plug it into this up here, -5, it breaks down, right? You get 0 over 0, so we don't know. But we can call up our buddy across the street over there named Lim Soup. No, not the Lim Soup. That's different, something else in a much deeper class, calculus class. But anyway, this is known as the limit here. We can call up our limit buddy, and he can tell us where this is at. All right. But what we're going to do is for some reason his phone's been disconnected, and hopefully it'll be back online soon. But anyway, what we're going to do is we're going to pretend we know how to solve the limit, but we're going to do it numerically, okay? And that means is we're going to pick a number that's, let's say, to the left of -5, and then and get closer and closer to -5, right? And then take a look at the y value, what it's associated with. And then we're going to come in from the right hand side and get closer and closer to negative 5 coming in from the right hand side. And we're going to take a look at what these guys are and what they're both approaching as we get closer and closer to negative 5 coming in from the left and the right. So to do this is you would take negative 5, okay, and we're going to subtract. Well, we're going to be going in this direction, right? So that's the same thing is, for example, 0.1, all right, 0.1. So this becomes negative 5.1, right? Negative 5.1. But you're taking this number and you're actually plugging it in up here. So negative 5.1 squared minus 25 over negative 5.1 plus 5. And of course we get that number. And then, you know, we just continue to do this. All right, do that, plug that in, right? That's negative 5.01. But we plug this in, right? And then we just write down what these guys are and continue to do that for however many you want to do, 3, 4 of them, whatever. And then what we're going to do is we're going to come in from the right hand side. So this would be negative 5 plus 0.1, which is negative 4.9. Right, so you're going to take negative 4.9 and then plug it in here, and take a look at that y value. And you know, we just continue to do this, coming in from the left and from the right, right? And see what this guy is converging towards. Now let's just go over to the web page here and hit the help button. All right. So coming in from the approaching negative 5 from the left hand side, as you can see here, we get negative 10.1, negative 10.01, and negative 10.001. So we can kind of get an idea that this thing is probably approaching 10, obviously. Approaching negative 10, sorry, negative 10. And then coming in from the right hand side, as you can see, we do the same thing, and both these numbers are getting closer and closer to each other, right? They're both converging towards negative 10, coming in from the left and coming in from the right hand side. So my guess is it's probably negative 10 is the answer that we're looking for. Alright, so you should be getting the hang of it if you've worked any of these other previous problems. Alright, so you go to math.com. See you there.